So the 3-5 prep paper in your hands. Tonight you need to read 3-5, and you also need to read about a guy. They put the guy a little earlier this time. I think he's right at the end of the reading. So as you're reading through 3-5, then there's a homework set. Flip another page or two, and there's a guy on page 75. They're going to talk about this guy through the regular reading, and then there's more about him on page 75. There's no theorem, not one theorem, definition, or postulate. It's a story. It's a story about something that a guy did. So what you want to look for, there's 5 total points in terms of reading through this. Just be aware of like what this story is. Who's this guy? What's he trying to do? How's it work out for him? Does he have success, failure? Like he's trying to figure something out. What's his answer? What is he even about, this guy? And then you find him on the page, and there's a little bit more about him in terms of his background story. But there's 5 points of reading, but not one definition, theorem, postulate, not one blue thing. It's just a story about something. And we'll talk about that tomorrow. The other parts of the quiz are here right in front of you. So let me for sure give you answers that are starting at 18. So 18, today you filled in the blank, hopefully with the word convex. So here's a definition of convex is for any points P and Q in the set, segment PQ is entirely in the set. So I'll say that again. For any points P and Q in the set, the segment PQ is entirely in the set. And then let me illuminate that with some pictures by strolling this way slightly. The first thing I have to explain to you is something the book never has and never will is there's a difference between a circle and a circular region. Does anybody know what the difference is already between if I talk about a circle versus I talk about a circular region?
Is the circle just the line and the circle region is on the inside?
That's correct. The circle is just the white outline of the circle. The circular region is that white outline, but it also includes everything inside. So here's the idea of convex. If I pick 2 points that are in this circular region, call one P, call one Q. If I play connect the dots, did I stay entirely in that circular region? Yes. Would that happen for every 2 points I picked, no matter where I picked them, of that circular region? If I pick 2 points in there, will the segment always stay in there?
Yes.
Yes. So this is convex. Okay, the ruling is convex is I pick 2 points that are in there, I connect them, I had to stay in there. So this is, yes, a convex shape. If I only talked about the outline, if I pick 2 points on the outline and I play connect the dots, do I stay on the outline?
Yes. Or no?
No, I'm cutting through the middle of empty space. That is not convex. A circle is not, because the circle is only the white outline, and I left the white outline. If I say triangular region, I pick 2 points in here. Do I have to stay in there?
Yes.
Yes. If I just say triangle, I'm only talking about the outline.
That's a maybe.
That's a maybe, and in geometry, maybe's the same as no. Okay. If I did pick my 2 points here, I'd stay on the triangle, but that's not enough for us. It has to work for anything I pick. If I picked one here, one there, I left this white outline and then came back in. So a triangle is a no. A triangular region? Yes. Parallelogram. If I just talked about a parallelogram, we'd say no, because that's just the outline. If I say a parallelogram region,
Yes.
now that's a yes. Because any 2 points I pick, I'm going to stay in there. What if I pick this region? No. Where could I pick 2 points that cause me to leave?
The leg split.
Like up at the top. If I make eyeballs on Sauron here, if I have these 2 points and I try to connect them, I have to leave and re-enter. That is a no, not convex. How about Pac-Man's region?
No.
No, because if I pick 2 dots here, I'd have to leave and come back in. Something that's convex basically has no hollowness or holes to it. If there's hollowness or holes to it, it's a no. If it's a solid thing, it's probably a yes. But again, the ruling was, if I can pick any 2 points that are in there and connect them with a segment, and the segment stays in there, that's yes. Convex, that's a lot what the homework's about. 19, for you to draw a set that is convex, you could draw any of the ones that I said yes to. But if you're showing me that it's a region, you'd have to like shade it in. So like, don't just draw me a triangle and act like that's okay. The triangle region that you show me by coloring in, that would be fine. 20 stayed the same of what today's was. Which postulate name is 20?
Separate.
Plane separation postulate is 20. The idea here is you have a plane, in drops a line, you separated this into 2 pieces. Skip down to 21. What are these pieces called? Half planes. We had a plane, and we just cut it into 2. They didn't get real creative with the name. Those are called half planes. This line has a name. That's called an edge. 23 is a different separation postulate. What's that? Space separation postulate. So 23 is space separation. If I have space and I cut it in half with a plane and now I've got 2 sides, what do you suppose those are called?
Half space.
Half spaces. And the plane that does that is the same name as like a surface on my box. What are the surfaces on shapes called?
Face.
Face. So that is a face. So those were the new ones today. That's what the homework is largely about today, are those things. Homework today is on page 65. There's a 1 to 13, largely dealing with those facts. So quiz, mainly a story, some more about a guy, check 75 and just read the story. 5 new points, there's the old points. Does anybody need more information on the first, like 17?